Hello, I'm Malcolm Campbell, and I want to share with you our new approach to teaching introductory biology. This book is also perfect for the redesigned AP Biology for high schools. The author team is composed of three faculty members at Davidson College. Laurie Heyer, shown there on the left, is a mathematician, and Chris Paradise on the far right is an ecologist, and I'm in the middle, molecular cell biologist. About the same time that the AP Biology curriculum was being redesigned and Vision and Change was calling for transformation of undergraduate biology education, we started to write this textbook. No other biology textbook met our goals of engaging students and introducing them to the excitement and process of doing science. So we decided to write a textbook that engages the students and teaches them how to think critically, apply the process of science, use quantitative reasoning, understand the integrated nature of biology, and understand relationships between science and society. We started out not with content, but rather considering how people learn. Our investigation led to several concepts that helped us develop the book. For example, we know that people learn best when they construct their own knowledge, when what they're learning builds from previous knowledge, and when what they're learning is relevant to them. Goals already defined, we consider the content, but in a non-traditional way. Our textbook uses framing questions that are answered using original data from the scientific literature. Students see and analyze real data. Integrating questions, as we call them, guide the students in the analysis of those data, as well as discern the main points, apply math, and construct their own knowledge. Our digital text aligns with both the recent AP Biology curriculum redesign and the Vision and Change initiative funded by NSF, AAAS, and HHMI. The way these three align is in their focus on core concepts, or what we call big ideas, and the core competencies, what others call transferable skills. Vision and Change core competencies are very similar to the ones I stated for our text. 1. The ability to apply the process of science. 2. The ability to use quantitative reasoning. 3. The ability to use modeling and simulation. 4. The ability to tap into the interdisciplinary nature of science. 5. The ability to communicate and collaborate with other disciplines. And 6. The ability to understand relationships between science and society. Several of these core competencies are specifically addressed in two pedagogical features. Ethical, legal, social implications, or what we call ELSIs, raise student awareness about the real-world aspects of case studies while they learn fundamental concepts. ELSIs help students grapple with their own ethical perspectives on emotional topics that relate to biology, such as evolution, stem cells, using animals in research, the cost and benefits of genetically modified organisms, and species reintroductions. Biomath explorations, or BMEs as we call them, help students understand how mathematicians can yield insights into biological concepts. The math is readily accessible, ranging from simple arithmetic, algebra, and geometry to more challenging examples in probability, statistics, and modeling. Laurie, our mathematician, has provided the content and pedagogy necessary for biologists to use the math while teaching biology. We assume no calculus experience on the student's part or the teachers. Let me also note that we consider you, our early adopters, to be visionaries and part of the ICB team. We are responsive to your thoughts on how to shape the book to meet your needs. We've developed a community portal where faculty can share ideas and post questions to the community. You can access this page at integratingconcepts.org, and I'll show that URL a little bit later. All of this has led to our development of a new approach to teaching biology. Students in our classes engage with each case study, LC, and BME prior to class and come to class prepared to discuss and analyze the data, ask and answer questions, and fully participate in the process of science. There are many benefits of the digital ICB text and the Trunity platform. Users get real-time updates free of charge, so we will fix broken links or typos, etc. Faculty and students have access to all the figures as PowerPoint slides. Faculty slides include pedagogy that we've developed to help students construct their own knowledge. Students keep their copies for as long as they want. Their access does not evaporate at the end of the year. Students can access their books from any device, including school desktops or their own laptops, tablets, and even phones. There's no need for the students to carry around big books anymore. You can adopt only the chapters you want and organize them in any order. E-books are much cheaper than paper books. It's $35 for 15 chapters, which is sufficient for an entire semester, or $70 for all 30 chapters, which should cover the entire year. Adopting fewer than 15 chapters increases the price per chapter to $4, but that's still very affordable for your students. We've embedded electronic content, such as movies, and interactive protein structures within the text. Adopters can author private sections of their own Adopters can author private sections of their own content to augment what we've produced. You can write lab or lecture material that only your students would see. We've produced 3 short videos that demonstrate online features of integrating concepts in biology, and you can explore those in any order that you like.